And let's knock out chapter 8, section 2. Right quick. And there's really only one thing that I want you to take out of this section. So let's go back and kind of retrace our steps with our exponents, since we've been in about, when we first saw them in our whole life, maybe like 5th grade. Okay? So, the first thing we were taught was when I had an exponent that's like a whole number, like 3. And I was taught that that's 5 times 5 times 5. So we know how to deal with that. And then about Algebra 1, or in beginning algebra, maybe for some of you, you had to learn what an exponent of 0 meant. And we even reviewed that in this class. We said if you raise any real number besides 0 to the 0, that you get 1. So we figured out how to handle a 0 exponent. Then we decided we better figure out how to handle negative exponents. And that was on your last test. What do you do with negative exponents? Well, you change the level. Okay, so for instance, I would need to move 5 to the negative 2 to the denominator, so it'd be 5 to the positive 2. That'd leave me a 1 in the numerator. So now I know how to handle negative exponents. So there's one kind of exponent left that we haven't learned how to deal with, and that's if our exponent is a fraction. What do we do then? For example, what would something like, say, 4 to the 3/2 power, what would that be equal to? What does that mean? So that's really what this section is about. Very short. So I'm going to tell you what it means. It's actually a radical. So here's how it works, okay? If you have some number, a, raised to a fraction power, let's say I had a to the m over n, I just said that that's going to be equal to a radical. Now listen, think about the word denominator and the word index. They both have a D in them, don't they? So put them together. The denominator becomes the index. Okay? So that n becomes the index. And then the radicand becomes the a to the m. So one way to handle a fraction exponent, or a rational exponent, is to change it to a radical where the denominator becomes the index and then the numerator becomes the power on the base in the radicand. By the way, that's also the same thing as the nth root of a and that whole thing to the m. And many times it's easier to think about it the second way than it is the first way. Yeah, but or you can use your brain sometimes.
Well, yeah, I just mean like whenever you put it in, you get 16 if you put it in like you did below.
Like it did. This shouldn't be 16. Let me show you. So let's check out 4 to the 3/2. See what that's equal to. So, do you see that the denominator becomes the index? So this is going to be a second root or a square root. Now you don't have to write the second root when it's the second root. Okay? So it's going to be the square root of 4 cubed. Or you could take the square root of 4 and cube the whole thing. Either way, you're going to get the same thing. Many times it's easier to do the second one. So class, what's the square root of 4?
64. 16.
No. You're step ahead of me. Some of you are here. I asked what's the square root of 4?
2.
And what's 2 cubed? 8. So this should be equal to 8. Now if you did this one, 4 cubed is 64. and then you'd square root that, and you'd still get 8. So either way, you're fine. Okay, it's just, this is gonna keep you in smaller numbers most of the time. That's why I usually do that. So 4 to the 3/2 power is actually equal to 8. Okay, let's do another one. Let's do 3 to the, I don't know, maybe 5/3 power. So the index would be the denominator, the 3, so we'd be looking for the third root of 3 to the 5th. Okay, and then that's going to give you some number. I mean, if you want to figure out what it is, that's fine. I'm not going to ask you to do that in your homework. But if you did want to figure out what it is, if you took the third root of 3, did the wrong thing. That would give you 1.44 blah, blah, blah. And then if you raise that to the 5th power, it's 6.240251469. Okay, but that's not really what I'm after. Here's what I'm after. Here's what I want you to do in your homework. Flip over to page 441. Let's do number 39 together. Okay, all it's going to ask us to do is to write this with a radical. It's not asking you to give the decimal or anything like that. It just wants you to put it in radical form. Okay, so Vanessa and Shiana, what's the index? 2. So this is a square root, and when it's 2, you don't have to write it. Brock and Billy, what's the power on the 10 going to be? 1. So, and you don't have to write the power of 1 if you don't want to. So on this one, you could just write the square root of 10. Okay, and that'd be enough. Don't have to do anything else. Right there, boom, done. Excuse me. So you could see a problem like that on your next test, or you could see a problem like this on the next test. I might reverse it. I might say to rewrite with exponents. And then I give you a radical. So maybe I give you the 6th root of 7 to the 5th. So you're going to have 7. You're going to have a fraction exponent. Remember, index and denominator come together. So 6 is going to be the denominator, and 5 is going to be the numerator. 7 to the 5/6. That's all I'm looking for. So all I want you to do is be able to convert back and forth between a rational exponent to a radical, and from a radical back to a rational exponent. That's all. Now, one last comment here. This explains something that we had earlier in the class. Do you remember that when we talked about the order of operations, we said parentheses first, then exponents, then multiply, divide, left to right, then add, subtract, left to right. But do you remember that when we said do the exponents, that's when we did our square roots? Well, this explains why. Because a square root is equivalent to having a power of 1/2. So it's really like having an exponent. So that's why way back in chapter 1, when we did exponents, we also did all our radicals. Because theoretically, a radical has an exponent. Okay, you just weren't ready for that then, but I'd tie that back to you now. Okay, so here is your very long and difficult assignment from chapter 8, section 2. It's page 441. I would like for you to do problems 39 through 42, and that's it.